Okay. They we are doing some problems based on the this topic here. Suppose let a subset of real number and if it's one of the function a to real number, then suppose this limit f of x lends to L is one of the real number, as s lends to a is finite limit, if and only if for every sequence Sn, right? You can take any sequence Sn in A that converge to A. That means Sn lends to A, like this here, Sn lends to A, here lends to A like that, here Sn lends to A, such that Sn not equal to A, right? Sn does not take the value A. For all n belong to natural number, we have f of Sn lends to L as n lends to infinity. Okay, here it is a necessary and sufficient condition for the sequence limit, right? Uh, this second part is the let a subset of real number, let one of the function f a to real number, then suppose this limit is exit. Therefore, because this limit is exit means it is a left limit, it's a right limit, right? Both values are equal to this L. Okay, it's called as a left limit, this is right limit. Some questions we can use these factors to show that whether this limit exit or not. Okay, right. Uh, these two under these two theorems, right? These two theorems, we do some problems, right? We do some problems now. First problems, you want to show that suppose limit of x tends to 0 cos 1 over x, sorry, cos 1 over x does not exit. The limit does not exit. You want to show that this limit does not exit. Therefore, we assume that the limit is exit. Then you can this theorem, then you can easily verify that this limit is does not exit. Because we arrive at the contradiction, then you can say that it is the this limit is does not exit. Okay. For this one, we assume that this limit is exit. You take your f of x, this one, cos 1 over x. Therefore, suppose that right, suppose that limit of x tends to 0 cos 1 over x, right? Cos 1 over x, ratio f of x exit. That means limit exit means that value is equal to, you can put another value, that is, we will write limit of s tends to 0 cos 1 over x, one of the value, this is your L. Now we use this first theorem, right? We use the first theorem, right? Is the first theorem. Consider a sequence Sn, okay, sequence Sn, such that your sequence of the form 1 over, right, 2n pi. Here your n is belong to natural number, right? N is belong to natural number. Therefore, first you check these conditions whether satisfy or not. This condition Sn is a that converge to a, right? Sn is converge to a Okay. Okay, right. Here, consider sequence Sn such that Sn equal 1 over 2n pi for all n belong to natural number. Now, your Sn, right, then your Sn lends to 0, right, as n lends to infinity. Okay, because you put here n as a n lends to infinity, you get Sn lends to 0. Okay, right. Uh, Such that this Sn does not take the value 0, right? Sn does not take the value 0 for all n belong to natural number. Why? Because suppose you put here n equal, right, n equal infinity case, you can take the value 0, but our theorem they mention here Sn, right, n length infinity, Sn take the value a, but Sn not equal to a, right? Sn not equal to a. It is our theory parts, right? You know, we verify that bus this part, right? Sn is conveyed to a such that a is 0, Sn conveys to 0, such that this condition is satisfying. Now you want to show that this f of Sn tends to L. But right, but here I already mentioned here. Here they asked to prove limit does not exceed. Right, limit does not exceed. Okay, for limit this does not exceed. Okay, for this limit is does not exceed. Therefore, um, right. Right. Okay. This limit is does not exceed means here you put here, right. Your this limit is does not exceed. This does not exceed for every sequence. Therefore, we want to do right here the for location part here. For every mean there are this a sequence Sn in A such that conveys to A such that Sn not equal to A for in block natural number. We have f of Sn does not lend to L as n lends infinity. Oh, this part. Okay, right. It is the location part of this theorems. Both theorems are there, right? Okay, right. Okay, now you understand, right? Now, then Sn lends to 0 as n lends infinity. Sn not equal to 0 for all n belong to natural number. Okay. Now, okay, now, right. Now, you you put this limit, right, in the function. Okay, but f of Sn, okay, f of xn equal, okay, cos 1 over, okay, Sn. But you have the form equation for the Sn 1 over 2n pi. Then you get cos 2n pi. Cos 2n pi must be 1, no? Cos 2n pi must be 1. Okay. Cos 2n pi must be 1 for all. n belong to natural number. Now you take the limit for this part, limit of n lends to infinity f of Sn. Okay, limit of n lends to infinity. Here your values of the f of x and 1. Then for any values of n length infinity, here 1, no, they have a constant limit 1. Okay, right. This limit is 1. It is your L. You to understand this limit is one of the limit value is a unique value. Okay, limit value is a unique value, right? Limit value is a unique value. Here in this problem, we do one of the particular sequence that limit is 1. We can take another sequence. Suppose that limit also 1, then we can say that it is limit exit. But we want to show that limit does not exit. Therefore, for that sequence, we want to get another limit values that not equal to 1. Right? Then we can say that suppose this. Okay, suppose this both for the two sequences, different limit values, but limit is unique. Therefore, this limit does not exist. Okay, that is the thing we want to do. Right now, you take another sequence. Okay, you take another sequence. If you take any sequence, this condition should be satisfying. You take any sequence for here, this condition should be satisfying in A such that Sn lends to 0. For A as a 0, no, that sequence lends to 0 such that that sequence not equal to 0 for all n belong to natural number. This condition satisfying, then here we choose the sequence, right, based on that conditions. Okay, based on that conditions. Okay, now your yn is equal to 1 over 2n pi plus pi by 2 for all n greater than n. Sorry, n belong to natural number. Okay, now since therefore, right, then your yn lends to 0 as n lends infinity. Okay, it's okay, right. Now, but what is your f of yn equal? F of yn means cos, no, cos 1 over yn. Yn equal this formula. Then cos get pi by 2 plus 2n pi. Cos pi by 2 plus 2n pi. Okay. Cos pi by cos 1 over n, right? Cos 1 over n. For cos 1 over n, you have this cos 2n pi plus pi by 2. Cos 2n pi plus pi by 2 means sine 2n pi. Sine 2n pi obviously 0. Okay, sine 2n pi means obviously 0. Therefore, if you take the limit x lends to 0, f of yn. This limit here 0, x lends to 0, sorry, n lends infinity, we get n lends to infinity 0. Right. Now, for one of the limit, you have two limit values. You know, you have L equal to 0, not equal to 1. I already mentioned you, right? This limit value is a unique one, right? We can't take two values, right? We take two values, both are equal. Okay. Here we found the distance values 0, distant values 0 and 1. Therefore, this contradiction, right? This contradiction means our assumption is wrong. When we take here limit exit, no, therefore it is wrong. That means limit does not exit. Therefore, limit of s lends to 0 cos 1 over x does not exit. Okay, limit does not exit. Okay, right? Limit does not exit. It is the problem, right? You understand this problem, right? In this problem, we use this theorem, right? Okay. That means you take two sequence, that two sequence limit are different, then you can arrive the contradiction. Therefore, you can say that this limit does not exit. Okay, you can do for this problem for the sine 1 over x also, right? We do here cos 1 over x. Okay, now we do another problems like this problem, right? That case also the limit is does not exist. Okay. Okay, right. Now do another problem. This exercise number 2. Right, exercise number 2. Right, exercise number 2. Exercise number 2 also like the same kind of problems, right? You want to show that this limit, right? So that limit of, right, x tends to 0 e power x cos 1 over x, right? This limit also does not exist. Okay, does not exist. Right. Okay, right, we'll do now. So you assume first you take your f of x. It is your this value, e power x cos 1 over x. Now, suppose that, right, suppose that limit of x tends to 0 e power x cos 1 over x exit. That is, you can write limit of s tends to 0 e power x cos 1 over x. This limit value is equal to L. Right? Now we can do these problems using this theorem. Therefore, we want to choose the sequence first. Okay. Therefore, first we take the sequence, consider, right? Consider the sequence Sn, right? Such that you want to choose the sequence Sn equal 1 over 2n pi. Appropriate way you can choose the sequence, right? For all n belong to natural number, right? Then you want to check the condition first. Sn lends to a. Here that means Sn a 0 no, then to 0 as n lends to infinity, and also this Sn not equal to a. Right? Not equal to a for all n belong to natural number. Therefore, what is your values of f of Sn? F of Sn means, right, e power Sn cos 1 over Sn. Now you put Sn values equal to 1 over 2n pi. E power 1 over 2n pi cos 2n pi. Now you take the limit of f of Sn n lends infinity. I think cos 2n by 1, no? Cos 2n by 1, therefore you get e power 1 over 2n pi. Now limit of e power 1 over 2n by n lends infinity. Suppose n lends infinity, 1 over infinity becomes 0. Therefore e power 0 should be 1. It is your L now. Right? It is your L now. Okay, it is your L. Now, now we choose another sequence yn, right? Right. Consider the sequence yn. Okay. Now consider the sequence yn. Okay. Consider the sequence yn such that your yn equal, okay, yn equal 1 over 2n pi plus pi by 2 for all, right? 2n pi plus pi by 2 for all n belong to natural number. Okay. In the previous problems, in this problem also we choose this, both are same, but in general we can't take any sequence. Okay, but right, we can take any sequence, right? Right, we can take any sequence. Therefore, but for this both questions we take this sequence, but you can for every, it's not a unique way, right? It is not a unique way. You can choose different sequences, right, to solve these problems, right? Okay, right. But here it is one of the appropriate way, right, to get the limit. Okay, yn equal 1 over 2n pi plus pi by 2, right? Point in this question, right? Now your f of yn, right? F of yn equal e power 1 over yn, no? E power yn, right? Cos 1 over yn. Okay, cos 1 over yn. Now you put this values e power 1 over 2n pi plus pi by 2 cos pi by 2 plus 2n pi. Then suppose this sign 2n pi becomes 0, then altogether you have 0 values. Is equal to yn, no? Yn means, okay, right, it's 0. Therefore, you take limit now, f of yn, n lends to infinity, you get the values again 0 equal. I already told you, right, limit is unique values. Therefore, we arrive here for a different sequence. We found two different limit values. That one here L, right, 0 and 1, but limit is a unique one. Unique one means both are equal, but here distance, therefore it is a contradiction, right? This is a contradiction, therefore this limit is, we assume that this limit is exit, but we arrive at a contradiction, therefore this function does not cap the limit, right? Limit of does not, this function limit does not exit, limit of s less to 0 e power x cos 1 over x, right, does not exit. Okay, cos does not exit. Okay, this limit does not exit. Okay, this limit does not exit. Okay, right. Okay, right. Now we do the another problems, right, under this theorem. Okay, right. Okay, now this exercise 3, right? Exercise 3. Um, okay, this example we can do now. Right, this limit of n length to infinity, limit of x length to 0, right? Limit of s length to 0, e power x sine 1 over x does not exist, right? So that this limit does not exist. Okay, so that exercise 3, so that, right, so that this limit does not exist. Okay, same, right? Same idea again we will do now, but we can use the x and y n different way for this question also. Okay, right. Suppose that, suppose that, right, right. Suppose that limit of x length to 0, e power x sine 1 over x exit. Now you put this is your f of x, that is limit of x length to 0. You put this is f of x equal to L. Okay, f of x equal your e power x sine 1 over x. Okay, now you can use the sequence, right? You can use the sequence. Uh, consider the sequence, okay? Consider the sequence Sn, okay? Sn, consider the sequence Sn such that you can choose one of the sequence Sn. Now we choose here 1 over n pi. 1 over n pi. Previous question we used the sequence 2n pi. I already mentioned, right? We can choose the sequence different, each of the questions, the s and y n are different, right? Sometimes may be equal, but some cases we are choosing the s and y n are different. Okay, now we choose 1 over n pi. Okay, 1 over n pi. Then, right, 1 over n pi for all n belong to natural number. Therefore, then Sn lends to 0 as n lends to infinity, such that this Sn not equal to 0, right? Sn not equal to 0 for all n belong to natural number. What is your f of xn value? F of xn equal, right, e power xn sine 1 over xn. Therefore, now your e power xn equal to 1 over n pi. Sine 1 over xn you get n pi. Therefore, sine n pi becomes 0, no? Sin n pi becomes 0. If n you put 1, then sin pi. Sin by 0. Sin pi by 2 only 1. Pi by 2, 3, 2 pi by, say, pi by 2 and 3 pi by 2 only 1, right? 1, it is, suppose you have here pi by 2, then it should be 1 this angle. But here sin n pi should be 0. Therefore, this 0. Now you to take the limit f of Sn n lens n sorry n yeah n lens infinity, limit of 0 n lens infinity. It is your 0 values L, right? It is your 0 values for L. Now consider another sequence, right? Now consider the sequence by n, right? By n, such that you choose by n equal, right? Choose the by n equal, what is the way? 1 over 2n pi plus pi by 2, right? By n over 2n pi plus pi by 2, n belong to natural number. Now, okay, now, then by n lends to 0 as n lends to infinity, right? N lends to infinity such that by n not equal to 0 for all n belong to natural number. Okay, now you have f of by n value. What is the value f of by n? F of by n equal e power by n sine, right? E power by n sine 1 over by n. By n equal 1 over 2n pi plus pi by 2. Then e power 1 over 2n pi plus pi by 2 sine 2n pi plus pi by 2, right? Sine 2n pi plus pi by 2. Okay. Sine 2n by plus pi by 2 means cos 2n by, right? Cos 2n by, then cos 2n by should be 1, therefore you will get 1 over 2n by plus pi by 2. Now, f of by n, right? F of by n, you take the limit, right? Take the limit of f of by n, n length infinity. Then limit of n length infinity, e power 1 over 2n pi plus pi by 2. Suppose n length infinity, 1 over infinity becomes 0, e power 0 should be 1. It is your L. Here you first case you get the values L equal to 0. For this case you get the values L equal to 1. Both are distance values. Therefore, but limit is unique. But here we arrived distance values for a limit. Therefore, it is a contradiction, right? It is contradiction, right? It is contradiction, right? Therefore, our assumption is wrong. That means here, suppose that limit of x tends to 0 e power x sine 1 over x exit, we assume that, therefore, that is wrong. Therefore, this limit of x tends to 0 e power x sine 1 over x, right? E power x sine 1 over x does not exit. Okay, does not exit. Okay, does not exit. Does not exit. Therefore, it is the sum These are the some examples of this theorem, right? Now we will do some problems based on this theorem, okay, based on that theorem. Okay, right. Okay, now find, right, x is 4, find limit of f of x s length half if it exit. Find limit x length to half f of x if it is exit, if it exit where this function is defined, f of x defined like this. Three intervals, first x minus 1 interval, when if x less than 2, x equal 2 case, right, its limit is x equal 2 case, limit is x equal 2 case, this limit is 1. Okay, x is 2 case, this limit is 1. X equal 2 case, limit is 1, here x plus 1. If s greater than 2, here 2. Right, okay. Now, for this question, we use this one. A subset of real number, and let if A to real number, then limit of S length to A, f of x equal L, if and only if limit of this is left limit, it is a right limit, both well. Suppose you take left limit, right limit for this one, both are equal, then you consider limit exit. It is your 2 minus delta, 2 plus delta. Here you can come to from this one to this one and this one to this one. Okay, it's okay. Therefore, uh, it is your right limit, it is your left limit, right? Limit of f of x s lends to 2 minus means this one, this limit, left limit. Okay, now how can you find this value? Limit of s length to 2 minus. At this case, what is the value? At this case, your value is less than 2, x minus 1. Okay, x minus 1. Okay, okay, right. Now, okay, we can keep here. Now, here, if you write this part, can I write this part? X minus 2 length to 0. Your s minus 2, you put, right, h, limit of h length to 0. You put here x minus 2h. What is your f of x? Here, x minus 1. Now you want to replace, right? You want to here you put x minus 1. You want to replace, right, x in terms of h. You take s minus 2 is h. Therefore, x equal h plus 2. Therefore, x equal h plus 2 minus 1. Therefore, it is now your limit is, we change the variables here, h length to 0. Now you want to take the limit h plus 1. Suppose h tends to 0, your limit is 1. What about this value? Limit of, right, f of s for right limit, half plus. Then here also you want to change the variable, you put x minus half your h, right? Right. Limit of your f of x, right? You put here h then the 0 means x minus half h. But here your interval is 2 here. Therefore, x greater than 2, you want to put x plus 1. X plus 1 means, right, x plus 1 means you put for x plus 1, h means x, sorry, here 2, 2 plus. Therefore, here, you know that here we can change the variables, right? Therefore, x, right, x plus 1. Yeah, here um, uh, you have x plus 1. Now you have x minus 2 your h, right? X minus 2 your h. Therefore, you put x as in term of x minus 2 plus 1. Okay. Um, Sorry, here, just wait. Some mistake there. For this problem, some mistake there. Just wait. uh, here for this part, if limit of f of x, okay, s lends to 2 minus, okay, this one f limit of s lends to 2 minus, you can write limit of f of, here you already know that I already mentioned here in this line 2 plus h, 2 minus h, okay. Now suppose here this 2 minus h greater than, sorry, less than 2, right? 2 minus h less than 2. What about f of 2 minus h? F of 2 minus h, what is the value? Right. In this question, we can do like this. Okay. First to understand, right? First to understand this part. Right. First to understand, if suppose in this line, it's your 2, it is some delta of h. Here 2 plus h, here 2 minus h. It is, suppose this limit like this. It is your left limit, it is your right limit. Okay, right. In this case, right, s less than 2 case, your function take the value x minus 1. S greater than 2 case, your function take the value, these values. Function take the value x plus 1. But s is equal to 2 case, your function take the value 1. Okay, function take the value 1. Okay, now now limit of f of x is lends to 2 minus, right? How can you find this limit? Right? How can you find this limit? If you want to find this limit, right, you want to change the variables here, right? Okay. S length 2 minus becomes here like this, from this point to this. Okay. Therefore, now we arrange the variables. How can you arrange the variable? Here, obviously 2 minus h greater than, sorry, less than 2, right? Therefore, f of 2 minus h. What is the value of f of 2 minus h? Here, less than 2 gets this one, s minus 1. You put x in the terms of 2 minus h, you get 2 minus h, right, minus 1. Then you have 1 minus h. It's okay? 1 minus 2 minus h, 1 minus h, okay. Then you put here h length 0, right, h length 0, f of 2 minus h. You put x is in terms of h, right. This one, limit of h length 0, f of 2 minus h means here h at this here. Sorry, here, this values from the list left limit, no, here. Therefore, this case is less than 2 case, x minus 1 function is defined. Therefore, f of 2 minus h means x your 2 minus h minus 1. Okay. 2 minus h minus 1 means we get limit of h length to 0, 1 minus h, no? 1 minus h. Suppose you take the limit for now, get 1. Okay. You take the limit, you get 1. Suppose for a right limit, right, for a right limit now we do for a right limit, you have some values here. You have the values. Right limit means 2 plus h greater than 2, right? 2 plus h greater than 2 means what is the f of 2 plus h? F of 2 plus h means here x plus 1. Therefore 2 plus h plus 1. Therefore 3 plus h. Okay, now it is your, okay, now h length 0, f of, right, f of 2 plus h, right? Understand? F of 2 plus h, we can say this point. F of 2 plus h, therefore limit of h length to 0, f of 2 plus h means here. Greater than 2, no? Greater than 2, x becomes 2 plus h. Here 2 minus h, x becomes 2 minus h case. Here 2 plus h, this function. It means 2 plus h plus 1. Therefore, limit h length to 0, 3 plus h. suppose h length is 0, you get 3, right? This limit of h length to 2 minus, right, f of x does not equal limit of f of x h length to 2 plus, right? Here, what is your L? L is your 1, right? L is your 1, but this one not equal to 1, okay, but this one not equal to 1, therefore limit of f of x h length to 2 does not exceed. Okay, limit of f of x does not exceed. H length is true because for a rep limit and right limit are different. Suppose you get rep limit and right limit are equal, then you can say that limit is exceed. Here, rep limit and right limit are equal. Right now, you understand, right? How can you do these type of questions, right? Suppose you want to find the rep limit, right limit, you can do like this method, right? Okay. Now another question. Right now, another question. Now another question. Find the limit x length to 1, right? F of x, it is exit. Find limit of f of x, x length to 1, if it is exit. Where your function f of x defined by minus 2x plus 3, 3x minus 5, if x less than equal 1, if s greater than 1, right? Same idea. Right now you have limit x tends to 1, no? Therefore, you have 1 here. Same idea, you can do it. Here, 1. Therefore, like a delta, then you get here 1 plus delta, delta your h. 1 plus h, here 1 minus h. It is your right limit. It is your left limit then. Okay, now limit of f of x s length to, yeah, 1 minus. 1 minus means denoted by 1 minus denoted by the left limit. Limit of here, similar like a first question, previous question, 1 minus a less than h. Therefore, f of 1 minus h. Okay, f of 1 minus h. It means see, minus h, 1 minus h less than 1. Therefore, what is your 1 minus h value? 1 minus h means you use this one. 2 times minus 2 times your x is 1 minus h plus 3. Then you get minus 2 plus 2h plus 3. Then 2h plus 1. Okay, 2h plus 1 means limit of, you put here h length to 0, f of 1 minus h. F of 1 minus h means in this case 1 minus h less than 1. Less than 1 is your, it is your 1 minus h now. Right? It is your 1 minus h now. Therefore, limit of h lens 0, right? Right, h lens 0, right? H length 0. Here you change the variables, right? Okay. Uh, Suppose 1 minus h length 0 means then your, yeah, 1 minus h length 0 means this x length, because 1 minus h equal x. Suppose x length 1 means 1 minus h length 0. Now you are 1 x minus 1, right? X minus 1 your h. Therefore h length 0. Right. Now f of 1 minus h, we get here 2h plus 1. Suppose you put h equal to 0, get 1. For a right limit, limit of f of x, x lends to 1 plus, okay, limit of x lends to 1 plus your function value here 1 less than 1 plus h. Okay, 1 less than 1 plus h. Therefore, what is your function value 1 plus h? You put here, because your x value is 1 plus h. Critical value for this one. Therefore, 3 times 1 plus h minus 5. Then get 3h minus 2, right? If 1 plus h, 3h minus 2. Here your h can replace h by 0. Then you get here 1 plus h. Then you get h length to 0. F of 1 plus h means 3h minus 2. H length to 0 means minus 2. Here both are different limit values. Therefore, using this theorem, we can say that this limit does not exist, because left limit, right limit does not equal. Limit of, right, limit of x length to 1 minus, okay, f of x not equal to limit of s length to 1 plus f of x. Left limit and right limit both are not equal. Therefore, this limit of f of x s length to 1 does not exist. Okay, does not exist. Okay, these are the based on the this theorem, right? This question based on this theorem, right? Next question. Next question also based on this theorem. Find the values of A. Find the value of A so that this limit is exit. Limit of x length to 1, f of x exit, where your f of x given by 3x plus 5, x less than equal 1, 2x plus a is greater than 1. Here they mention limit exit at x equal to 1. What is the limit value? You take here limit of f of x, x tends to 1. What is the limit value? Here, in this case, you're going to put the values because s greater than equal, less than equal 1. Equal 1 here. Therefore, limit of 3x plus 5, function value 3x plus 5, s length to 1, you get 8. Okay. Here, this limit is exit, means you want to take the left limit and right limit, both are equal, because limit exit, it means left limit equal to right limit. First, you take the left limit, limit of f of x, x length to 1 minus, is denoted by as a left limit. Okay, right. Limit here, right here, you take here, what is the point? Limit 1, therefore 1, here 1 plus h, 1 minus h. Okay, now obviously this 1 minus h less than 1, therefore uh, your function less than minus, your function take the value this one. What is your 1 minus h? This is your 3 times 1 minus h plus 5. Therefore 3, 5, 8 minus 3h. Okay, 8 minus 3h, your function value for this case. S length to 1 minus means your h length to 0, f of, right, you put 1 minus h. Now you limit of 1 minus h means x, right? Okay, this f of 1 minus h becomes 3 minus 3h plus 8. Therefore, you get 8. Okay, left limit 8, okay. This limit also 8, okay. Right, now we consider the right limit. Right limit means, right, limit of f of x s length to 1 plus, therefore limit of f h length to 0. Here for a right limit, your 1 is there, here 1 plus h is there, 1 minus h is there, obviously 1 plus h greater than h. Therefore, your 1 plus h value should be f1 plus h means greater than h, means here, sorry, greater than 1. Greater than 1. Therefore, the value is here. Here 1 plus h. Therefore, 2 times 1 plus h plus a. Then you get 2 plus 2h plus a. 2 plus 2h plus a. Right? 2 plus, here you put here 1 plus h. So 1 plus h. Now limit h tends to 0. 2 plus 2h plus a. Suppose h tends to 0, you have a plus 2. But they mentioned this limit is exit. Therefore, this limit equal to this limit. This limit value is 8. Therefore, a plus 2 equal to 8 and equal to 8. Therefore, a plus 2 equal 8. Because limit exit, therefore a plus 2 equal to 8. Therefore, a equal to 6. Okay. A equal to 6. Okay. This limit exit means this limit equal right limit. Then you can equating, then you get the values of a. Right? Okay. These are the based on this theorem and this theorem, right? This theorem verify some questions and some question based on this theorem, right? Okay.